Welcome everyone once again to IMC 2020. My name is Akhilesh Tuteja. I'm delighted to have with me a wonderful set of panelists today to talk about a topic Industry 4.0 revolutionizing workspaces and industries. There couldn't have been a better time than today to talk about how Industry 4.0 or technology in general could change our workplaces. Industry 4.0 has the power to transform the way we work, not just in our corporate offices, but also in factories, the way we operate and the way we do everything going about our work. I have with me a wonderful set of panelists today. I'm delighted to introduce them very quickly. I'm joined today by Arnab, who's a Vice President Global Service Line for Advanced Network and IoT at Capgemini. Welcome, Arnab. I'm also delighted to introduce to you Digvijay Sharma, who's a Senior Director Sales at Ciena. Followed by that, I have got Neeraj Bhatia. Neeraj, thank you for joining us today. Neeraj is Senior Director, Enterprise Sales, Red Hat, and he's got tremendous experience on dealing with this subject. I would like to hear a lot from you, Neeraj, today. Sanjiv Kapur, who's another stalwart in the subject. Sanjiv Kapur went on to co-found a company which he's now a CTO also, the company called Truminds. Truminds is focused on developing use cases and solutions for Industry 4.0. Sanjiv, we look forward to your insights. I also have the pleasure of introducing to you Sundereshwaran Raman, fondly known as Sundi. Sundi is the Senior VP of and Head of Product at Airtel, one of the companies which I love. I also have the privilege of introducing to you Thomas Noren. Thomas joined us from Ericsson. Thomas has a number of different responsibilities. He's the head of dedicated networks and vice president of digitalization, IoT 4.0, 5G, and private networks. Last but not the least, and trust me, we have Xavier Kurian, who's a director of solution and alliances at Dell India. I couldn't have asked for more. So thank you, IMC, for putting this 2020 edition. While we are not in person, but we are having more than compensated for the quality of speakers which we have been able to get to you today. No other format that other than this would have got us such a wonderful spectrum of people to talk about today in IMC 2020, the theme being smart, secure, and sustainable. A topic like this can take different shapes and forms, and therefore I'd like to try and make it in a manner so that we get the maximum out of it today. I also recognize that the people who have joined us today come from very different backgrounds. Some of you are on your own expert in the area of this topic, and many of you might be hearing it as a topic of interest to gain more knowledge about it. So to make the topic very interesting, I'm going to start very simply with the simplest question I can ask. And my first question goes to Sanjiv. Sanjiv, we've been talking about Industry 4.0, fourth industrial revolution, and many other terms like that for a long time. I always keep getting confused when people talk about generations, and there is no industry to be blamed more than the telecom industry. Talk about the 3G, 4G, 5G, and by the way, not to forget 2.5G also somewhere in between. So I'm always confused. What is the connection between the G and the industrial revolution? I'm sure there is none, but somewhat it is. I'm a little bit confused when I talk to you guys. So let's start with one simple question. Sanjeev, how do you explain Industry 4.0 to a fifth grader? Sanjeev, you're on mute, please.
Oh, I'm sorry. Yeah. Hi, Akhilesh. That's an interesting question, and probably, at the risk of oversimplifying this, I would like to say that Industrial 4.0 means, adding another dimension to the manufacturing process, and, that is data. So, I would, oversimplifying this, I would say that Industrial 4.0 is all about data. If we expand this a little, it means collection of data, manufacturing data, analysis of data, and automated actions on the data. And if we take a little deeper, this means all the latest technologies, all the latest technological advancements to enable this, such as sensors, connectivity, Internet of Things, machine to machine interactions, as well as connecting them to humans and other applications. Big data technologies, cloud analytics, which is very important aspect of this, which gives what needs to be done on the data. But the gist is that Industrial 4.0, I would say, is all about data. So that's the other dimension that has been added to this.
Most of the interesting things these days actually go wasted because people were speaking with all the based on their mute. So I did the same part. But thank you, Sanjiv, for summarizing that Industry 4.0 is about data. And on a lighter note, I'm happy that I'm not going to the fifth grade now because I wouldn't have cleared by your standard of fifth grade. It was a little complicated for me. But I think I'm sure the fifth grader these days are far more intelligent than what I was when I was a fifth grade. But thank you so much. I think I really like the aspect which is that it's all about data. How do we take the manufacturing to the next level? And who cares about the theory? Who cares about what does it take? And I'm sure there are going to be several definitions. I leave that to Professor Klaus Schwab. When he wrote the book about the fourth industrial revolution, I'll go and whatever he said is the kind of the gospel truth. But I think what we all are here to look at is that how can we make our industrial workplace smart? How can we use the power of technology and, Sanjeev, as you mentioned, the power of data to make decisions? How can we move away from machines which are being controlled by human action to the machines which make their own decisions? How could we take advantage of all the intelligence which are built around computing systems to be self-contained in those machines which run our production systems? So I think that is really the fascinating world which we are living in. Many times we don't realize the speed with which automation happens. Because we are in it is very difficult for us to realize how fast things are moving. And that is something which we can only imagine when we look back. So the industrial revolution which started out has taken a very different shape. And I'm absolutely fascinated about what the future could hold. So let me invite Neeraj. Neeraj is from Red Hat and is another expert on the topic. Neeraj, what do you think could be the potential future for Industry 4.0?
Thanks. I think as Sanjiv said and Akhilesh, as you kind of spoke of, Industry 4.0 is truly about data and its intelligent utilization. Right, and that in itself is the most critical success factor of the industry. Also, lies and as a technology landscape, I think India and worldwide, we as a generation are making good headway. But what is currently needed is the availability of a lot more integration through low latency, high bandwidth networks, standardization of our IT platforms, the ability to integrate all of the various technology landscapes that we have, which are running our industry, our factory, shop floors, which are collecting all of that data. All of that needs to be collected, cleaned up, processed, and intelligence needs to be derived. Intelligence that allows this data to then control our processes through robotics, as we call it, move toward an artificial intelligence and an augmented reality part of the industrial revolution. Now there is another dimension to all of this, which is the technology that will make all of this more palatable or more consumable and much more easier to manage and engage with. That's where a lot of IT technologies and transformations come in. Technologies like cloud, containerization. Where we take application, take all its and take an application, take all its dependencies, put it into a small container. By small I mean small IT footprint, and make it run on a standardized platform, whether on-prem or on cloud, and then bring in automation for all of this to interact with each other and bring in least and to be able to manage it with the least IT intervention. That to me, I think, is the direction that we are getting to. We've seen sci-fi movies that talk of robots controlling lives and world. I think we have to stop just short of that. We have to build enough intelligence and train all our existing manpower, reskill them to be able to direct this the Industry 4.0 in a way that it can help us scale and prepare for the next millennium right, and do a lot more with a lot less we are currently used to. So I think that to me is where this is headed, and that's the future direction that we have.
Fascinating thoughts, Neeraj. I kind of picked up some very interesting cues from your talk. One, you talked about that it is all about getting closer to what the possibility could happen in some of these areas where the technological developments are happening. I like your reference to sci-fi movies. While I'm not a movie buff, but I love some of them. Being the husband of a Shah Rukh Khan fan, I do watch some of his movies. And when I think of Industry 4.0, I have to get reminded, and sorry for those folks who are listening in from another parts of the world, not from India, I'm making a reference to a Bollywood movie called Om Shanti Om. And in that, Shah Rukh Khan says that if you desire something so badly, the whole universe conspires it to make it happen for you. And I think the Industry 4.0 kind of looks like that. And, because we desire it so much, the whole universe is conspiring to make it happen. So we've now got intelligent sensors, we've got the power of data, we've got great algos, we've got all of those things in terms of computing power, cloud. But sometimes people say connectivity, which is like one of the most important aspect of that universe trying to conspire that to happen. So let me turn that on that point to Arnab. Arnab, tell us how important the role connectivity plays, and has connectivity really heard the desirous request from Mr. Sanjiv?
Oh, yes, absolutely. And one cannot less emphasize the need for connectivity in any human interaction. When we communicate, we are connecting over the ether, and we are speaking face to face, though not off late. When we communicate over a platform like this, which is tailor-made and optimized to transmit video data from all the participants in the most optimal fashion. So every bit of real-world scenarios need the communication bit of it to be optimized, customized, and really designed to serve those use cases. So when we talk about Industry 4.0, and I think your reference, Sanjiv, and Neeraj's reference is spot on, that data plays a very important role in Industry 4.0. But how do you collect that data? How much data is involved? How much data is needed to train your models to do a closed feedback loop, which can make the machines operate on their own? That is the vision of Industry 4.0. So how the devices or different types of devices will generate that data, how efficiently you can collect it, what kind of time frames, how much latency of turnaround time between data being generated, transmitted, processed, and goes back into the machine. So what is the time frame between these two things? So these are very important parameters which depends, on which the success of Industry 4.0 will depend. So as we know, there are many types of connectivity options, how machines can talk to one another. And it's a really, disaggregated world of options. There is low power RF, there is wired, industrial Ethernet, Profinet, and it's a real jungle out there on what kind of connectivity options are there to be used in industry. But there is light at the end of the tunnel. At least it's visible. So keeping in mind the true vision of Industry 4.0, the folks at 3GPP and other organizations which drive these technologies that you were talking about, 2.5G, 3G, 4G, and nowadays 5G. So when 5G vision was conceptualized on how it should perform, what kind of connectivity it should offer. Obviously, we as consumers want to use the more and more bandwidth, etc. But there was a specific attention given to how 5G technology can be used in industrial context. There were specific recommendations that the industry bodies actually gave, which went into the charter of how connectivity works or should work in industrial context, because there are very special needs. In a manufacturing environment, there are a lot of metallic surfaces, there are a lot of reflections, a lot of interference, a lot of electromagnetic interference, as opposed to the type of connectivity we use at our home. So this is a step in that direction, and some of the pieces of connectivity, especially when we talk about 5G, there is the so-called release 16 of 5G, which is coming out next year, although the early trials are already happening very successfully, and I'm sure Thomas is here from Ericsson might have a viewpoint on this as well, on what can this kind of connectivity that 5G can offer to simplify the networks within the industrial context. How we can take the wires out of the equation, and then the whole scenario changes where you can implement use cases of moving robots or collaborating robots or discrete factories which are not fixed. You can literally set up production lines on the fly and reconfigure your production lines simply because you're able to remove the wires and yet get very reliable connectivity within the industrial context. And that, I think, will be a very important piece to see how soon the vendor ecosystem, the devices, because technology is one thing, trials is one thing, but for the technology to scale and really bring the economies of scale, the economics have to work out. The device price points have to go down without compromising on reliability. So in short, connectivity is a very important piece of Industry 4.0 because that's what gets the data onto the platforms which needs to compute and apply the intelligence. And 5G holds a lot of that promise on simplifying that aspect of connectivity from a deployment standpoint. And I'm sure some of our colleagues will talk about millions of devices talking simultaneously and generating very large amount of data, and yet it is able to meet millisecond level latencies. So all of that is the promise of 5G. We are seeing some very interesting green shoots on what 5G can do in the industrial context. We ourselves at Capgemini have run several trials with our large industrial clients in automotive and aerospace, and the world is really on the cusp in 2021 to see Industry 4.0 now scale with connectivity coming into place.
Fascinating, absolutely fascinating, Arnab. I think you created a much higher degree of curiosity, at least in my mind, about connectivity. Sometimes something which we kind of ignored. You started your conversation saying that as we are speaking, we are communicating in ether, something which I don't see, I don't care, but it is so complex, so important. You talked about the reflective surfaces, the current quality, and the power management feature. There's so much. I'm sure tons of engineers are working in the background to solve this problem. But I, at this point, would like to turn to Thomas, purely because my urge about connectivity hasn't fully been fed. So I think I have a follow-up question to you, Thomas. Tell us a little bit more about where Arnab left us in terms of what 5G can do, and of course some of these coming up. But one specific thing which I would really like us to talk about is the focus on private networks. What do you think is the role of those, and how can they really help us? And what should people like you and me be worried about or thinking about as we build the future Industry 4.0 systems?
Thank you. I'd like to build on what Arnab, talked about. I think one of the key challenges, of course, we have all these fantastic technologies with AI and machine learning and so forth. You still need a way to collect all the data, and you want the way to steer those machines for Industry 4.0 and so forth. And that's what 5G was also designed to build. But the good news is actually this also, that already with 4G, you can do quite a lot. And many enterprises, they face a challenge with the communication systems that they have today, being PMR, LMR systems for direct communication between workers, or Wi-Fi systems that they've tried to build out, but that you can't achieve the coverage or security with. So if you look at this point in time, we see a lot of demand from not only from manufacturing, but also from airports and from mines and from ports, from utilities, oil and gas, a host of industries that just want to invest to replace and make the existing legacy networks that they have already today future-proof. So they can start to do video communication between workers. So they can start to have smaller handsets, so they can have less operational costs for the networks that they have. But they want to make those investments, of course, in technology that's also future-proof, that will enable, 1 millisecond communication latency to connect robots and all the nice things that we have demonstrated in the labs. So there is already now a compelling reason to invest now, and then be future-proof for Industry 4.0 and the use cases that are emerging. And the fantastic thing about that is, of course, that then we will be able to leverage the enormous scale of, in particular for devices, that 3GPP brings in 4G and 5G. That will take down the cost points for chipsets. It makes it possible for gateways and industrial devices to be affordable, because they can piggyback on the enormous smartphone volumes that are generated from the macro networks, the billions of devices that are sold there. I think this is why dedicated networks become very important. And you realize also when we talk to we work at Ericsson, our customers are the operators. And we don't have an own enterprise arm. We work with system integrators like Capgemini, for example, to go out to the market and support our operator customers. But we still try to understand what is our customer's customer, what do they need? And it turns out that they have across those industries, they have pretty generic communication needs, but they want to have much simpler networks, and they want to control them, and they want to have something that is pre-packaged and pre-integrated. That's what they want. And this is what we are then offering now with dedicated networks.
Interesting. So I think I'm seeing a huge amount of development happening, and we talked enough about the dedicated network and, of course, 5G. I love the point, Thomas, you mentioned that we don't have to wait for 5G. We can do a whole lot just with 4G. That's satisfying for someone like me, because I always hear that all the problems will be solved, but not now, tomorrow. So I'm happy that there are some problems being solved. With that, I would like to turn to Cindy from Airtel. He deals with some of these interesting use cases and does many different things. So Cindy, I would like to hear some of your perspective on what do you think is the art of possible? What the kind of things which we can do? Starting to thread from Sanjiv and then moving to Neeraj, Arnab, and Thomas, we said that so much is possible because there's so much data, so much of possibilities. What do you think is the art of possible for people you deal with when it comes to Industry 4.0?
Yeah, thanks Akhilesh, and thanks for inviting me to this panel. So we at Airtel, because we get to see a wide array of clients trying to connect their devices, we are a little bit more fortunate to actually understand what problems they're trying to solve. And while Neeraj and everybody talked about how important data connectivity is, and the possibilities can be anything. And the movie that Terminator is a notion of what that is completely industrial 4.0, but somebody wrote that movie probably 2 decades ago of what machines can do and where it can go wrong or right. But based on where what we are seeing the evolution right now, at least from a more of a tangible, practical reality where we are, at least in India and globally, what we are seeing here is that the companies are trying to move, and because of all this pandemic we are in, it has actually fast-tracked some of the investments in the M&D or industrial community are trying to. Typically, they are not very, they're more conservative than some other companies who are born digital. So they came from physical and now they're going to digital. But we are seeing a trend where they are starting with very small use cases, and these use cases are coming from the fact that how do I get to a better place in improving my experience of the customer? And what do I mean by that is they have sold a device or something to their end. So I'm talking about from a consumer side, and I'll get into the industrial piece, because there's a notion that a lot of these manufacturers are actually selling devices to consumers like you and me, and they have to actually provide an experience where they can proactively solve those issues of maintenance and all that. So how do I get my devices smarter? So that is basically an area where they are investing a lot right now. So getting from a device that is cannot be, it's out there somewhere, they don't know anything about it, but somebody says it's not working, and it takes days or weeks for them to send out a technician to fix it. How do I go and do that immediately so that the experience I provide to my customers are improving? And these are very small, very specific use case with a huge ROI associated with it. Many of the clients we are speaking to right now are constantly coming back to us about, can we do this in terms of cost efficiencies, the modules that we have to get, because connectivity is there. Because now, as you also talked about, and Thomas also talked about, with 4G, we can do a lot more things. We don't have to wait for 5G to do it. So one use case we are seeing is this whole notion of how do I get my support experience, my assurance to my end customers. That is taking off. So that is a very, very, very clean thing that we are saying. Then there are customers like we work with Nokia in this case. Their factory in Chennai, if you go and visit that, that is actually completely automated. So from the fact that and we use their private LTE, we power their whole automation through our private LTE network. And if you go visit that, that's a classic example of what Industrial 4.0 should look like if you visit that factory. So we are seeing some of these, and I would say they are more ahead of the time in terms of not everybody in India would be able to do it, but they have shown what is possible. That's for me, like they will know which element is there in which bin, and the whole supply chain is automated, the whole machinery is automated and all. So that's the extreme possibility. Then we are also seeing with customers where they're trying to, manufacturing in a factory where you have a lot of these moving assets, the cranes, the trucks that are going, hauling from one unit of the factory to the other. How do you track them? And how do you do just-in-time production? So that's another use case of that we are seeing a lot in some of the manufacturing companies we are working with. So again, here you're basically using the existing 4G connectivity. In some cases, we are able to provide dedicated connectivity through private LTE kind of solutions, but they are trying to move towards making their operations more efficient. Right now, that's where they are. Where the humans or their assets, the other assets, people that are actually doing this job, how do they take them out of the drudgery of doing this manual labor, but assist them with some technology, which is the IoT technology or Industrial 4.0, putting some more intelligence into a device, collecting the data, enabling this workforce to maximize their productivity, and actually driving the throughput. So one is on the maintenance and predictive maintenance, then going into getting their operations more efficient within the factory premises, but more on the fact that where they can actually reduce the time a human spends on doing a job and making their life better, right? And then with that, they're actually able to produce more of those same with a lower cost. These two, and then the final piece is like, once you have some of these, the cost that comes down, because one of the pieces which is very important for industrial IoT to also be taking off is the fact that the unit economics also have to work. The devices need to be turned smarter. You need to then pull the data, store it. So there's cost involved in all of those aspects. So as the cost goes down, as more people adopt it, then the possibilities is what I will say the movie Terminator was. Like robots are doing it. There is a cost efficiency of deploying a robot to do it, because today you can't deploy a robot just like that, because you have to train the model. It will do a lot more work to get to that state. That state will be there, but I think the journey has just started in terms of what people are trying to do right now.
Interesting. I think Sanjiv gave a number of different perspectives, connecting dot with B2C to B2B, and I like that we moved away from Bollywood to now Hollywood. And you talked about Terminator 2 decades ago. I will talk about Iron Man. And the way you describe some of these use cases, I get reminded of the quote from Tony Stark, and he said that sometimes you got to run before you can walk. So looks like that those are the kind of use cases you're talking about, that we are running at faster pace, not everywhere, but at least at some places. So let me turn the attention to Sanjiv. Sanjiv, thank you so much. What I would like you to take on is, what you are seeing similar to what Sundi talked about, some of these interesting use cases, or give us a broader perspective of what again could be the art of possible when it comes to the solution you are providing to people.
Yeah, thanks, Akhilesh. And I think Sundi mentioned a lot of interesting use cases. I'll just carry forward that and to add, some of my observations. Of course, as Sundi mentioned, so productivity, operational efficiency, that is definitely one of the most, useful and important use case. We are also working with on many solutions, implementing them in many industries in India as well across different sectors. White goods manufacturing or automotive industry, where we are connecting, all the traditional machines like welding machines, molding machines, taking their data and which we could never imagine, but a lot of analytics can be derived from these sort of machines as well, and which can give a lot of feedback to increase the productivity or to reduce any production losses. Not to say, all the latest machines like CNC and robotic machines. And we have seen overall equipment effectiveness (OEE), which is an important parameter in manufacturing industry. How to derive that from these parameters collected from so many different types of machines in a plant. How to aggregate that? How to correlate that? And if somebody in management is getting that in real time, that is of immense importance to them, to ensure that everything is running to its full capacity. So these use cases, of course, are pretty, pretty sort of obvious as well. But I just want to highlight some other interesting use cases which we came across, and a very interesting or very important thing is worker safety. That Industrial 4.0 can be used for worker safety as well. A very interesting solution that we're working on, with one of our customers is, smart industrial hats. Now, industrial hat, it looks like a commodity, right? We have seen it, construction workers wearing, but we could never imagine that this could be an intelligent, connected device and could be of such an importance. So we are working on solution where this device has so many sensors, which can measure the temperature, the ambient temperature, the body temperature. It can, let worker do an audio conversation with the backend. It can transmit all that data to the cloud. It can, in the hat, it can enable, video streaming from whatever, it can see around in the factory. And that is being used in cases in, hazardous industries like mining, steel, construction, to avoid any, undesired accident or any such incident. Now, that is purely for, worker safety, which is, which could be another interesting aspect of it. And another use case which we did recently, and which I think all of you can relate to, it was safety during this pandemic times. So we developed a solution. There are mobile apps, where but the challenge is that mobile app somebody has to switch on for social distancing to making sure that all the workers are maintaining the safe distance, etc. But mobile app has to turn on, and you cannot make sure that it is turned on at every case. So we developed a solution with a customer where there's a device inbuilt with which only does the measures the distance between the workers indoors, with not relying on GPS, which doesn't work indoors, but relying on other techniques which work indoors, whether it is Bluetooth beacon or RF technology, and ensuring that the safety, the social distancing, and all those compliances are maintained during these times. So not only productivity, not only operational efficiency and increase in productivity, but Worker safety could be another interesting aspect which we came across, and that was, one of very interesting use cases which I just wanted to share with all of you.
It makes me laugh, I must say that, because when you talked about not just the use cases about making life easier using productivity and efficiency, but also safety and dealing us in this time. And when you talked about the simplest thing like workers' hat and making a smart workers' hat, I got reminded of the smart toilet seat. I thought that was a bizarre enough example where these days the toilet seat will actually be able to take a poo sample and will be able to tell you what you ate yesterday wasn't good enough. And so I know where all this smartness is going, and I hope it doesn't go too far and breach my privacy and many other things. That I'll turn to Xavier. Xavier is from Dell, and he's got tremendous experience of doing some of those things. Not I talked about the first one about the smart toilet seat, but about the broader industry 4.0. Xavier, don't get me wrong. I don't go around what you do, but he's got some great ideas. But Xavier, the question to me is not about the art of possible. The question to me is how is it possible? Because there is also, while we as user can see great things and we watch things in movies and think it all happens, but it's not that easy. So can you throw some light on the complexity of challenges and what does it take under the hood for some of these things to happen, and what would be your advice to people before they kind of embark on the journey?
So Akhilesh, let me answer this and stepping back a piece, right? So in my worldview, we've been doing Industry 4.0 for the last few years, right? And in fact, I'd say an example like the one Sanjiv gave some time back on worker safety. We've been doing it for quite some time. A really long time ago, I saw a cutting machine that would detect a hand within the cutting machine and not cut if a hand was in place. That was very early automation of processes. But today, if you look at where Industry 4.0 is going, it's not only about the factories. It's about the industry of agriculture. It's about the industry of dairy farming. Every one of these industries or so-called industries that we have out there has the potential to go improve or make machines or get machines to make decisions to improve productivity or to improve supply chain goodness, efficiency of the entire supply chain. And I'll give you a couple of examples, right? In agriculture, the color of a leaf can define the taste that can get delivered to an end product. If you can collect that data across 1,000 farms that you are buying the greens from, and then go recategorize that into taste categories with a predetermined set of data, you can make your supply chain more efficient, charge more for the tastier, and the rest of it can go at standard market prices. There has to be value that can be derived from each one of these changes that we make with Industry 4.0. Whether it's improving how we go procure or improving how we go run our factories. In one of our Dell factories, for example, every piece that comes onto the manufacturing line is tagged. The machine knows exactly where it is. And if you went and gave me a tag of a machine 5 years later, I can tell you exactly which factory, exactly which transport mechanism was used for a screw to come into onto that machine that delivered to you. So it is about having a track on everything that you do and using that track to improve efficiency. Now, while we are going in and deploying this, there are three things that we've realized that you need to go and think about. One is, what is the data that you go collect, right? What kind of sensors are you going to use? What kind of data do you need to go collect? The second big decision to go make is how much of that data needs to be backhauled all the way to the data center. Where do you process that data, and how much of that data do you go and store? Right. For example, in in the greens example that I gave earlier, you need not store 5,000 hours of video that the plant grew entirely, but you do need to store, let's say, 40 photographs of all of each plant each plant that grew. That data needs to be back out to the data center, processed, and you need to arrive at an algorithm that defines the taste. Then you don't need the photograph anymore. So what you do, where you process the data, how much of that data you keep, and how you end up using that data is the second piece of the puzzle. The third piece of the puzzle is standardization. And when I say standardization, and I think Neeraj touched a little bit on that, but standardization is about being able to share that data. And I'll give you an example of that as well. We did a study with a trucking company that was doing the average speed during rain and while it was raining and while it was not raining, or how weather impacted transport times. Right now, you think that this is not much of an impact, but the damage rates go up, the accidents rates goes up, and the total time that an item takes to reach from point A to point B, and therefore commodity prices and all of that goes up depending on the weather. Is there a way to go start tagging this to a weather model and predicting more accurately how much the supply chain needs to be moved around? That's IoT, and that's Industry 4.0. Sharing data from a weather service to a trucking company to a logistics company, all the way down to the manufacturing floor. And that's going to be possible only if you start standardizing how you collect the data and how you store and how you process this data. So, three things. First, how you collect the data. Second, how you process the data and where you process the data. And third, and most importantly, how you go standardize this so that you can go share all of this across multiple industry points. Now, while we've done all of this, we did it with we've done projects like these with the dairy farm, with the agriculture in the agriculture industry, and we've obviously done it in the larger manufacturing factories as well. The big piece that we learned long term is that it is impossible to tell today what data you're going to need tomorrow. Right? So the ability to go use that data and connect that data back into your data center and go create reference points on that is going to be critical to the long-term success of Industry 4.0. That's my 2 cents on it.
Thank you, Xavier. That's certainly more than 2 cents, but I think what I took as the major takeaway is 3 things. What do you collect? How do you collect and store and process? And the third one is how do you standardize or use that so that it's not just for one purpose but many. Thank you so much, Xavier. We've lost the video for Arnab. I hope he's able to hear me and can come back on video. That'll be nice. Let me turn to Digvijay first with an apology. Digvijay, I'm coming to you at the end, but sorry about that. The question I have for you is, we've heard so many things. We heard what I4.0 is. We talked about what's the various components which make happen, connectivity, we deep dived into the use cases and all that. We also heard some of the challenges. Coming to you, what do you think are some of these challenges which are still unheard of, things which we haven't really looked at? Even talking about connectivity, what works, what doesn't work. Give us some things about what are the areas, and you frame this question that we started out with saying, how do you explain I4.0 to a 5th grader? How do you explain to the CEO of a company what are the things they should take care as they embark on I4.0 journey? Digvijay, you're on mute.
Very nice question, Akhilesh. Thanks for giving a good question, even if it comes at last. I think it has, in my mind, there are 3-4 key ingredients that makes Industry 4.0 into a reality. The first part is the hardware piece, the sensor, actuators, and things like that. I'll explain why and how. The second piece is the software piece, who processes this thing and how well it processes. And the third piece is the connect piece. And the fourth and the foremost important piece is the security. How securely these devices are connected to each other. And the fifth piece is the consolidated, controlled processing of it, taking meaning out of everything, all put together, something to which Xavier very clearly articulated. So I'll keep that piece to Xavier's explanation. He has very nicely articulated. I would not like to touch that. But getting on to the hardware piece, the hardware piece is very important because because any intelligence starts with data collection, and then that data needs to be processed, and then that data needs to be transmitted. Because whether there's a richness in the data collection. Again, Xavier captured it very well when he was talking about whether should we capture 400 hours of video or we capture photographs. That piece is very important. The right data points are being captured, and then they are rightly processed at each point. So that processing, that's where the compute part gets into the equation. And then the transmit piece. If we are computing whole lot of data, the transmit piece, the load on the network is going to increase drastically. Now, this piece of hardware, if we are talking about $1 million robotic arm, you would put a very nice server into that robotic arm, because it's $1 million, few thousands of dollars doesn't matter. But if you're talking about sensors, let's say you're talking about a car or a GPS system into an automobile, which Sanjiv spoke about. So, or a hat, these sensor and these processors, the cost of each of those things matters a lot. So the question comes up, the piece of hardware, at what cost points you are getting, and what kind of compute power that you want to deploy onto those. So that is one key piece, because if the devices are not rightly priced, the adoption of technology would be low. Classic example which Sundi can also suggest is that if you take 4G was not adopted till the time devices are cheap enough. They are not in 7,000 to 10,000 bracket. So hardware piece, the way there has to be a lot of focus that should go on what kind of hardware, where you are putting intelligence, where you are collecting data, and how much data you are collecting. That is the hardware piece. The second piece is software piece, where software defines how much you would process, how much of intelligence should reside in that device, or how much intelligence we would like to have at a central location where all this data is collated and processed. So software piece is the second key element part of it, and then third piece is the connect piece. The connect piece, unless right now, even if we see today in all the industries, there is a lot of the compute resources there in all the CNC machine, as Sanjiv spoke about, in the trucks and at various other places. But all this data, there's a lot of data, but that is residing within those devices, those robotic arms, so to speak, or maybe at a factory level. But the true Industry 4.0 would come in with all these individual ecosystems connect together, and we make sense out of everything end to end. Classic example is that, if we talk about retrofit, whether it is an automobile industry or it is any manufacturing setup, the component failure happens in field, but it starts with a solution, or a product failure happens in field, but if we do the root cause analysis, it lies with one of the component which is sourced in one of the part and by 2 or 3 suppliers, and probably in one of the few batches. Unless we have the right data collected and at each of those points to a central location, the processing of this data will not be possible. So all these devices needs to be connected, and the data needs to be collected from all those things and need to be reposited at a central location wherein these things can be processed, and some meaningful process improvements, cost optimization can be done. And the next piece is that while we are talking about all these devices getting connected, these devices, whether they are video devices, whether they are moving cars, whether they are robotic arms, the connection between them needs to be secure. It has to be encrypted. not only at the device level, each machine to machine connectivity, but also to the level of when all these big data are being transferred between one location to the other at 100 gig levels also. So the encryption and the security piece of this data is also very important. And third, and the foremost important piece is that where this data is getting computed and responses are provided, the feedback part. These feedback can vary from industry to industry, like if, and also onto the problem that we are solving. If you're talking about vehicles in mines, the driverless cars, the feedback needs to be very fast. So the processing needs to happen at edge, which leads to some models like mobile edge compute towards the edge. Localized data centers should be there. If you're talking about problems like sampling the data, tracking problem that Xavier mentioned about, there can be a big data center residing somewhere in cloud. So four things, Akhilesh. First part is in order to make industry 4.0 reality, the cost of hardware, the capacity of hardware, that is one key element. The second piece is the software. In India, I think software is a piece that being powerhouse of software for the world for software, I think that comes easy. And trust me, all kind of industry, small, big, large, have a role to play depending upon different use cases. So software is an easier problem to solve in India among the lot. So software, hardware, software, connect, and security, and then the compute, the centralized storage and processing part. These five key elements come to my mind.
Wonderful. I think you very well summarized. Coming to the end of this conversation, I think
there's one piece that I want, and I completely agree, Digvijay, but there's one very important piece with every IoT project that there has to be ROI, which is why I believe that the early days are going to be those low-hanging fruits where the savings are substantial. And as these costs come down, there's going to be more and more use cases that make economic sense. But the pitch to a CEO is find a way to go save money. So, and Industry 4.0 can save significant money.
Thank you, Xavier, for coming. I think Digvijay summarized it well. But Xavier, I like to add on to say if you're talking to the CEO, talk money because that's the only language they hear. So I think that's a good summary. I do want to thank IMC once again because they did a wonderful job of pulling together such a fascinating panel. But I also must say that you've given us very little time. I wish I had more time. We could go on and on and on. So much. I have so many more questions in my mind. But before I leave, and I think we've got, maybe I'll just stretch for just 2 minutes. My final question, back to Thomas this time. Thomas, there are many other aspects of I4.0 which may not be so easy and so good. It's being about cost. It's about challenges with respect to the current workforce. Many other fears around it, the ROI and something. But one thing which is very close to my heart is the issues around cybersecurity and privacy. Do you have any suggestions as people deploy such solution? What should they keep in mind with respect to cybersecurity and privacy?
So I think it's a very good question. A very common request is, of course, that you want to protect your data on site. You don't want it to live anywhere. It's very integral. It's not just that you need to have it running with 99.9999 percent availability. You also don't want to leave important data to leave your site because you want to have total control. It's so integral part of your competitiveness. And this is one of the reasons actually why enterprises want dedicated networks. The communication as such over 4G and 5G is very, very secure. It has never been broken. So that piece is secure. Now, if you can also make sure that the data doesn't leave the site, then you're 100% safe.
Thank you. I think that was insightful and assuring that while there are many other concerns, but the data in such communication networks, especially private networks, is very secure and also can be encrypted. As I said, that I could go on for many, many hours and quite awkward. I'm very conscious of everyone's time. I would just like to summarize 3 or 4 different areas. We started out saying I 4.0 can mean many different things, but it is all about data. Thank you, Sanjiv, for giving us that angle to start with. I heard a whole lot about how I 4.0 is built on power of algorithms and intelligence. Great use cases around productivity and efficiency, and not just that, but also making our lives easier and safer using some of the other examples heard from Sunday, Sanjeev, and others. I would like to end by saying that Industry 4.0 is here to stay. It is here to make our lives easier. As Xavier and Digvijay talk to us, they make sure that you take care of some of these challenging aspects. And not to be forgotten, it is the time, Xavier, I repeat your statement, it is the time for us to go for those low-hanging fruits. Let's prove the power of this technology and the ecosystem of technology for all of us. And borrowing from Thomas again, it is never a perfect way to start anything. We don't have to wait for 5G. 5G will come and make our lives even better, but we are already moving. And going back to Tony Stark, sometimes you got to run before you walk. I think this is one of those. I'm fascinated to have moderated this session, talk to many of you. I have personally enriched, and I'm sure all of you who are following us, listening to this conversation, would have found it very interesting. Thank you very much once again, and have a good day.